Okay, so first let's just review what we talked about in last week. It's been a week, okay, for the topic. So let's just review a little bit. Last time we talked about the isotopes, okay, and we also talked about isotope master one that already specific telling you what is the number of proton, what's the number of neutron, and what's the number of electrons. So then you can tell what is the isotope. And we talk about what's the difference between isotope and the general elements, right? If we just talk about elements, then that's just a simple on the periodic table, okay? But if you're talking about the isotope, that means you have to specify the mass number, right? Because in the isotope, you already know the proton, neutron, and the electron. So you generally can write down what is the symbol for the isotope, right? Just like here. If you write just the potassium, nothing else, then that's elements. But if you write the potassium 39, then that shows this is an isotope, okay? This is one kind of the atom belong to element potassium. Okay, so that's very important. And we also talk about the how to write the average atomic mass. The average atomic mass generally is just using the isotope, the mass for the isotope, and multiply their abundance, and you got a result. You have another isotope mass time abundance, you got another result. As long as you add up those results, then you got it. Okay, you even don't have to average again. Okay, so once you're doing this process, you are already doing the weighted average. Okay, it's already doing the weighted average. Okay, so this is isotope and average atomic mass. And we also talk about the periodic table. Okay, we talk about in the periodic table, we have A, or called the main group. We also have a B group, or called the transition metals. And in the majorly, we're only focused on the main group or A group. Okay, so the A group, 1A is called the alkaline metal, 2A is called the alkaline earth metal, 7A that's halogen, 8A is a noble gas. Okay, and also the reason we're group those elements is because they have a similar chemical or physical properties. Okay, yeah, and we also talk about in the period. Okay, in the period, left side always is a metal, right side always is a non-metal. Okay, and in the middle we have a zigzag shows over there, something like that, right? Zigzag shows over here. This is the boundary between metal and the non-metals. And on the side of the boundary, and we have some of the elements is called a metalloid. Okay, metalloid. But just to let you know, most of the cases, metalloid in nature behavior like a non-metal. Okay, the metalloid in nature is a behavior like a non-metal until they are under certain condition, then they behavior like a metal. Okay, yeah. So most of case like a silicon, you can just write the silicon. Most of cases it's just a long metal. Okay, and as they experience very high pressure, higher voltage. Okay, high voltage, then this guy will become a metal. And also we talk about the bonds compound. The compound has a ionic compound and a molecular compound. Those are all chemical bonding, but the chemical bond is different. The reason it's called the ionic compound is because they are having ionic bond. And the ionic bond actually is just the positive ion and the negative ion, they are attract to each other. The attraction is what we call the ionic bond. Okay, the attraction is what we call the ionic bond. But for the molecular compounds, they do not have a ionic bond. Generally, they are having a bond between atoms, right? The ionic bond is the bond between ions. So the ionic compound actually is a cation plus anion. The cation anions having bonds, but the molecular compound is two atoms. The two atoms, they're having bonds. So that is the difference. Okay, and we also talk about to identify whether it's an ionic bond or molecular bond. You can just based on the formula, you can identify, because the formula, the first one should be the metal, and the second one should be the non-metal. Then in this case, this guy definitely is ionic bond. If it's a metal, if like water is non-metal, and the first hydrogen is non-metal, oxygen also non-metal, and this is belong to molecular compound. Okay, molecular compound. So this is a easier way to identify ionic bonds or molecular bonds for those two atom compounds. Okay, and also we talk about how to write the formula. If I give you a cation and anion, how to combine those two cations and anions together, making a correct formulas. Okay, make a correct formula. And the one thing you need to make sure is the molecule is always neutral. You never see, okay, just let her know, in the nature, you never see a stuff that only have a cation, or a stuff only have an anion. That's impossible. Okay, that's impossible. They always want to have a cation and anion they put together, because in the nature, charged particles is not exist. Okay, they always try to find something the other side. Okay, they always attract the other side, because those charged ion is not stable. Okay, they try to, the molecule actually is, okay, so if you think about the molecule is just it's lazy. Okay, they always try to find the lower energy level. Okay, they always try to be stable. The charged particles is not stable. Usually they have a very high energy, so they want to have another part combined together, make it lower. Just like okay, human being will always, most of the people, I mean, I would like to, okay, if I can, so in China, we also, what do we talk about? We talk about, if I can sit, I'm not going to stand. If I can lay down, I'm not going to sit. Okay, so this is in nature. Okay, yeah. So they always try to be getting a stable or lower energy levels. So this is the nature of those, any of the particles. So if they have a charge, they always try to find another one, make it a lower level energy. Okay, yeah. So you're not going to see any of the charged particle alone. Okay, unless it's in the environment, cannot let it go. Okay, cannot let it. So that is why molecule always a neutral. So if you have a positive charge, they have to have a negative charge. They balance to each others. That is why when you balance these particles, you need to make sure the charge are equal. The positive charge and the negative charge are equal to each other. Then in this case, you can easily to balance the particles, right? And we talk about the easy way is just to have the positive charge number go down to the negative anion. The anion, the charge number go down to the cation. Then that should be balanced, just like this. Okay, so we should have a 2 aluminum ion to balance with 3 of the oxide ions. And we also talk about in the ionic compound, we always write the simplicity ratio, right? In the ionic compound, we always write a simplicity ratios, okay? And we also did the practice, and generally this is pretty much what we talk about. And we just mentioned a little bit how to figure out the ions, the charge of the ions, right? So that's why I give you the common ion sheet, right? Everyone has the common ion sheet? Okay, have a common ion sheet. So the common ion sheet actually is showing, give you the general idea what is the charge. What's the charge for the cations or anions, or including a lot of the polyatomic ions. Okay, but in general, I I hope you can still remember some of the cations that has a charge, or some of the anions was a charge, because the elements in the periodic table, they give you the rule. Okay, for example, I'm going to remember that metals always making a cation. Okay, so this is what we're going to have a talk about more new things. Metal always has a cation. Okay, so usually you can find the metals, the charge of cation usually is just equal to the number of group. Group number. Just equal to the group number. Okay, so for example, 1A group, you have a sodium ion, lithium ion, potassium ion, rubidium ion, and Sicilian ions. Okay, so they always has a one positive charge because they're in the 1A group. 2A group is the same. You have a beryllium ions, you have a magnesium ion, you have a calcium ion, 2 positive, and strontium ion, and barium ion. Okay, yeah, so they always has a 2 positive. For the 3A, we're talking about aluminum. Aluminum has a 3 positive charge. And for the rest of the other elements, generally they also has a 3 positive. But those are elements we're not commonly talk about, but they are still follow the similar rules. Still follow the similar rule. So gallium, 3 positive charge, and indium, 3 positive charge, and polonium also 3 positive charge. Okay, yeah, so this is usually the common things we see. The metal always, if they lose the ion, generally the positive charge is equal to their group number. Non-metal also has a similar rules, but this also has a trends, but not exactly the same. For the non-metal, and the non-metal usually has a negative charge, which is an anion. Non-metal always, especially for those non-metal, usually has the anion. Okay, usually has an anion, but their charge, the charge actually is equal to the cation, their group number minus 8. And again, 8 will be the magic number in chemistry. A lot of things is with 8. Okay, so for example, if we talk about 5A group, 5A group, then like nitrogen and phosphor. Okay, most common is nitrogen and phosphor. Arsenic. Arsenic is a transition, is the metalloid. So usually we're not talking about that. This guy has a 3 negative charge, and this is also 3 negative. Why? Because 5 minus 8 is equal to minus 3. So that's 3 negative. Okay, 5 minus 8, that's a negative 3. So this guy has 3 negative charge. 6A group, like oxygen, sulfur, and also selenium. This guy has a 2 minus and 2 minus and a 2 minus. So they have a 2 minus charge. Why? They have a 6A group minus 8. That's a negative 2. Okay, so that's a 6A. 7A group, halogen. They have a fluorine, chlorine, and iodine, bromine. So those are minus, just 1 negative charge shows up here. That's because we have 7 minus 8, that's a negative 1 charge. Okay, so those are pretty common. And if you talk about the noble gas do not have a charge because they are noble. They're not going to react with others. They are just stick as intact. Okay, so this is generally the rule for those monoatomic ion. Okay, so that's why I hope you can remember at least some. Those are the 1A, 2A, 7, 1A, 2A, 6A, 7A. Okay, so in this case, it will help you speed up the solving the questions, and I mean easily to balance the equations or balance the formulas. Okay, all right. So this is what we talk about the monoatomic ion. Then here we're going to talk about the polyatomic ion. Okay, we need to specify what is a polyatomic ion. So polyatomic, okay, monoatomic, mono means one. Okay, so monoatomic, that means this ion only made by one atom. Okay, yeah. But the polyatomic ion is made by multiple atoms. Okay, it's made by multiple atoms. And the polyatomic ion could be cation or anion. Okay, if you're looking at the here the common ion sheet, you will see not so many cation are polyatomic ion, but there's a one very common ions that we're using for the cation is this one. This is called the ammonia. Ammonium. This is called the ammonium ion. Okay, ammonium ion. This is ammonium ion. Okay, or you can just call it ammonia. Okay. So if you're looking at this guy is made by one nitrogen atom and 4 hydrogen atoms all together. So this guy is a group. They are having a positive charge shows up there, but this positive charge not just belong to hydrogen, it belong to the whole particles. Okay, so you can see generally the structure is something like that. In the middle is a nitrogen, and then they have a hydrogen on the side. This is structure, and the charge is belong to the whole particles. So in general, polyatomic ion, you suppose looking at the polyatomic ion as a one particles. Okay, so you can just assume this guy is just a one particles and has a one positive charge. Okay, so you cannot separate the particles inside of the polyatomic ion. They react when they react, they will react as one. Okay, so the particles when they move, they always move as a one. Okay, so you cannot separate those polyatomic those particles inside the atoms inside the polyatomic ion separately. Okay, when they count, they always count together. In another word, if you have 2 polyatomic ion, 2 ammonium ions, generally the atoms of nitrogen and atoms of the hydrogen will also double. Okay, so if you have a 2 ammonia, you're gonna have a 2 nitrogen and 8 of the hydrogens all together. Okay, so this is you always looking at the particles as a one particles. Okay, so now then that's gonna be our question. If this ammonia is combined with chloride ion, which has a one negative charge, then it's easy, right? Since this guy has a one positive charge, this guy has a one negative charge. So when they combine together, make a formula, and then that's just ammonia and the chloride. Ammonia and chloride, they combine together, that's it. But what if you have ammonia and you have a sulfur, which has a 2 negative charge? Then Well, obviously, we know to balance those, we need to have a 2 ammonium ion. Because 2 ammonium ion has a 2 positive charge, then we can balance one of the 2 negative charge of there, right? But when you write the formula, you cannot write NH4, right? We know the 2 should go underneath of the ammonia, 2 and the sulfur. You cannot write like this, okay? Remember, when the people start to using the formula is the time that we do not have a computer. Everything is handwritten. Okay, seriously. And most of the scientists has a really bad handwriting. Okay, so what if you write 4 up there, you also write 2 up there. They're gonna make the people very confusing. Okay, and we know if you change the molecule, the structure a little bit, the numbers a little bit, it could be different, completely different things. So that's why to avoid this situation, you have to have a parenthesis to cover the polyatomic ion. And the 2 outside of the parenthesis is talk about how many modification for this polyatomic ion. Okay, how many numbers of this polyatomic ion we have. So the 2 shows we have 2 of the ammonium ion, and the 4 means we have a 4 hydrogen inside of the ammonium ion. Are you clear? Yeah, so this is very, very important. When you're in the formulas, if you have a multiple numbers of the polyatomic ion, you have to have a parenthesis to cover and put the number of that. Well, this makes sense, right? Writing this makes sense because you know, okay, we have 4. We should have a parenthesis and put a 2 up there. But what if we have another one? Okay, let's see. We have a barium ions. This is a monoatomic ion. And we have another one. So anyone know what is the name of this? OH minus. Looking at the polyatomic ion, the third one. That's called the hydroxide. Okay, and hydroxide is how you make the base. Okay, how you make the base. When you have a OH ion in the solution, then that's called a base. Okay, yeah. Hydroxide ion. So this guy, you know, we have a barium ion. It has 2 positive charge, and we have a hydroxide which is one negative. And remember, the 1 negative charge is not just on the hydrogen. It belongs to the whole particles. Okay, yeah. So, and you know, we should have 2 of the hydroxide ion, right, to balance the barium. So a lot of people writing like this, and they think they're done. Is it right? No. BaOH2. This is not right. Okay, so if you write like this, what does that mean? To everyone think about, in this case, I have a 1 barium. In this case, I have a 1 of the barium, and I have a 1 oxygen, and I have a 2 hydrogen, right? But when you write, you should write as a barium, and we should have a 2 of the hydroxide. But in 2 of the hydroxide, you should have a 2 oxygen and 2 hydrogen up there. Okay, so definitely this is not correct. What you need to write is a barium and have a parenthesis and add a 2. But just let you know, even you know it, you still can make a mistake, just like this. Okay, so you need to make sure you have a parenthesis to cover the polyatomic ion. Although this looks like not like a polyatomic ion, but it is a polyatomic ion. Polyatomic ion means this ion composed of more than one atoms. If they have more than one atom, then this is a polyatomic ion, although it may not look like. Are you clear? Okay, so this is how you write a polyatomic ions. If we go some like extreme situation, we have ammonia, right, ion, and we have two of the polyatomic ion combined together. This is ammonia, and we may have another one. This is a nitrate. Sorry, not a nitrate. Let's see. We have a carbonate. Carbonate has a 2 minus. So ammonia combined with 2 carbonate. One of the carbonate with two negative charge. And we know this guy only have 1 positive. This guy have a 2 negative. So we should have 2 ammonia to combine that. That makes sense, right? Then you're gonna have ammonia. Make sure 2 of the ammonia, which is putting 2 of there, and combine with the carbonate. And this is ammonium carbonate. Ammonium carbonate. Okay, so for a compound, they can be both polyatomic ions. Okay, they can be both polyatomic ion. Are you clear? Any questions? Okay. If you don't have a question, I'm going to ask: is this a is this what kind of a compound it is? We have 2 different kind of compound. What kind of compound it is? Is ionic or molecular? I hear the difference. Somebody says ionic, somebody says molecular. This one is ionic. Okay, remember why? Ionic. Remember why we call this ionic? Because they have ionic bond. What is the ionic bond? It is a positive charge and a negative charge. They attract to each other. Is this a positive charge and a negative charge attract to each other? Yes. Both are one is a cation, one is an anion. They attract to each other, so they are making an ionic bond. So this is an ionic compound. Okay, so this is an ionic compound. So that is why we're going to extend what is the definition for the ionic bond. Ionic bond is not just first it's a metal, then later it's a non-metal. I mean, if you have a first elements is a metal, then later is non-metal, for sure that's an ionic bond. That's an ionic compound. But some of this, if you have a polyatomic ion as a cations and an anion all together, this is also an ionic compound. Okay, you got it? Okay, so this is so this is ionic bond. All right, so let's look at our page. Please open the page 20 on the Blue Study Guide. Page 20. And page 20, there's one more thing I need to mention, and then you can work on those practice. Yes. Okay, so the page 20, if you're looking at one questions in the middle, one of this in the middle, which is a mercury, they have a Hg2 plus and combined with chloride ions. Okay, so first I need to talk about what do you think for this kind of the compound, or for this ion, for this Hg2 plus, this ion, what do you think? Is this a monoatomic ion or polyatomic ion? Think about the definition. This is a poly, okay? Because I mean, 2, it shows a 2 of there. Okay, this shows of 2. That means this kind of the ion actually made by 2 mercury. So generally, they have two particles, two mercury, and make the overall charge of this two has a two positive. It doesn't mean it has each. It means each of the particles has a one positive charge, but those two particles actually is combined together. It's not separately. Are you clear? Okay. So this is a polyatomic ion. Then you need to think about these particles as since particles has a two positive charge. That makes sense, right? So if this guy has a two positive charge, then we try to combine with one of the negative charge. What is the formula it could be? That should be just M, Cl, and 2. Makes sense, right? And when you replace this M to the polyatomic ion, so you suppose write Hg2, Hg2, Cl2. It makes sense, right? So that's gonna be the correct formula when you combine those two together. And then I know you're thinking about it. You think about, wait. Are you talking about something wrong? I mean, previously you just mentioned when we talk about the zinc and oxygen, this is 2 plus and this is 2 minus. You said we're not going to write zinc 2 O2. But why this is good, but this one is not right? Yes, Trace.
Because you can't separate it.
Yes, because this one you cannot separate it. This is a polyatomic ion. You cannot divide this. But this one you can, right? This is the zinc. We don't write the zinc 2 as a polyatomic ion. This guy is a monoatomic ion. So you can simplify those guys. But this one you cannot because this is a polyatomic ion. You cannot divide the polyatomic ion into a simplistic region. Are you clear now? Devin, do you have a question? All right. So this is what I mentioned over here. Then you can go ahead to work on the study guide shows up there. I'm going to give you you can just work on this. That's fine. Yeah. Yes. Go ahead to work on the questions. Just writing the page 20, the formulas. You don't have to give the name. Okay. Just write the formulas. We will do the name later. Okay. Just write the formulas. Okay, so let's start to review this. Okay, and just to let you know, okay, when you write the polyatomic ion, if there's only single one polyatomic ion in the polymer, you don't have to write a parenthesis. Okay, just leave it as it is. Okay, you don't have to write a parenthesis. Okay, yeah. So let's just review. For the first one, that's silver, 2 silver, and then chromate. So that's a silver chromate. Then you have aluminum sulfate. And you have a barium hydroxide and calcium hypochlorite. And chromium oxide, chromium 3 oxide, copper 1 sulfide, iron 3 nitrate, mercury 1 chloride, potassium permanganate, lithium carbonate, magnesium nitride, sodium hydrogen phosphate, sodium dichromate, ammonium phosphate, lead-2 acetate. And just to let you know, this is a typo shows over here. That should be C2H3O2 instead of C2H3O3. Okay, so that's a typo. That's an acetate. And then tin 4 oxide, tin 4 oxide, and the zinc oxalate. Zinc oxalate. All right, so this is the practice to making correct formers up there. So let's take a little bit break, and then we will talk about how to write the name. Okay, how to write the name. Okay, from the former or former to the name. Yes.
It's just plus sodium.
Yeah, so we have 2. Did I write?
Yeah.
Oh, yeah, so there's the 2 over there. Yeah, there's a 2 over there. Okay, yeah.
Same thing for this one, would it be 2 please?
No, we should have the 2 oxygens. So this one you can simplify, right? This is 2, 15, 4, so you can simplify.
Okay, yes.
So that's okay. Okay, so let's come back. Okay, let's come back. The next part we're going to talk about the naming. Okay. Here I'm focusing on the naming for the ionic compounds. Okay, majorly we're talking about the ionic compounds. Later we will talk about the molecular compound. So the naming of the ionic compound. Ionic compound naming. Okay, so majorly the very straightforward. And again, ionic compound is made by cation and anion. So as long as you know the name of the cation plus name of the anion, then you got the whole name for the compound. For example, you have sodium chloride, right? And you know sodium is made by sodium ion, and chloride is a chloride ion. And if you're looking at the polyatomic ion, then you will see the sodium ion actually is just called sodium. So usually, most of cases, a metal ion is just the name of this metal. Okay, yeah. So sodium is just called sodium. Sodium ion is just called sodium. And then the chlorine ions is a little bit different. The chlorine is called a chloride. If you're looking at the formers, you will see in the monoatomic anion, they give you it's called a chloride. It's called a chloride. So that's why cation plus anion is just called a sodium chloride. Okay, sodium chloride. Okay, so this is called a sodium chloride. But one way, okay, first we're going to talk about the cations. Cations is a little bit specific. For this ion, sodium, yeah, there's only one kind of sodium ion, which is only the sodium ion with one positive charge. But for some of the elements, they could have a different type of the ions, like iron. Iron can have two positive charge, and also they could have a three positive charge, which means those are two different kind of iron. But if you're talking about, okay, metals ion is just equal to their metal's name, so both are called iron, and then you cannot tell the difference, because when you write the formula, you need to make sure what is the charge for this cation. Okay, then you can, based on the charge of the cation, to write the formulas. So in this case, you don't know. So that's why you need to specify the charge of this. So that's why this guy is called iron, and you need to specify what is the charge of that. So write a Roman number of 2. So this is called iron 2, and this one is called iron 3. Okay, iron 2 and iron 3. Copper also can have the same thing. Copper sometimes has a copper 1, and also they have a 2 positive charge. So the first one, this is called the copper 1. And the second one is called the copper 2. And once again, those are need have a parenthesis. Okay. Once again, do you know why it is called a parenthesis? They need a parenthesis. Remember, scientist has a bad handwriting. Okay. Yeah, seriously. Yeah. So what if somebody write this as a copper 1? Well, a lot of people may recognize that this is a iodine. Okay, yeah. So you have to have the parentheses to separate those. Okay, yeah. Make it be clear. Okay, making it clear. So this is why you're gonna have a parenthesis to cover it. Okay, so this is how we write the name for the cations. Some of those you need to specify. And then that's gonna raise another question, which is, give me a second. How can I know which elements has a multiple different kind of ion? I don't know, right? How about silver? Do you know what is this? Is the silver has only one charge or different kind of ions? You don't know, right? Are those chromium has a multiple ions? You don't know. Is the manganese has a multiple ions? You don't know, right? Lead or arsenate. How can I know? Okay. So that is why I'm giving you the common ion sheet. Go to look at the second page of the common ion sheet. Okay, yeah. So if you're looking at the periodic table, second. Second page of this common ion sheet. Okay, yeah. Then you will see the periodic table, and then on the top of the periodic table, some of the ion is already specified. All right. If they write multiple different kind of ion, that means that this guy, when you write the name, you need to specify. Like a silver, is a silver need to specify? You need to write silver 1 in the formulas, in the name. You don't have to, right? Because silver only give you one kind of the ion, which is just a 1 positive. So you don't have to specify, right? You just write silver. That's it. Okay. Like a potassium, you don't have to write potassium 1. It's just potassium. But when you write the chromium, Cr, the chromium has Cr has 2 different kind, right? One is a Cr2, one is a Cr3. So you need to specify it's maybe a chromium 2 and chromium 3. Are you clear? Okay. So, and also later, if you write potassium chloride as a potassium 1 chloride, then that's not right. Okay, yeah, this is not right. You should write potassium chloride instead of potassium 1 chloride. Okay, yeah, this is not right. Okay, yeah, this is not right. Okay, so that's why some of the ions you need to specify. So when you write the common ions, you need to make sure, is this specified or not? Is this specified or not? Okay, so this is a common ions. Then let's talk about the anion. Let's talk about the anion. The anion could be the different options. For example, we have a cation. The cation could combine with a monoatomic ion. The name of the monoatomic ion, if you're looking at it, is always end with something something ide, something something ide. Okay, yeah. So when we name those monoatomic ion, they always is a name of the elements. And then you probably need to taking off some of the endings. then plus the ending IDE. Okay. Sum of the ending of the IDE. So that's why we call something IDE. For example, we have a chlorine, Cl. This is called a chlorine. And then you get rid of the ending INE. Then you plus IDE of there. So this will give you chloride. Give you the chloride. And if you have a fluorine, it's a FLUORINE, fluorine. And then you plus the IDE, get rid of the ending, and then that's called a fluoride. Okay, and if you have oxygen, again you plus IDE, get rid of the ending over here. This is called the oxide. You have a nitrogen. Plus IDE, get rid of a lot. Then let's give you nitride. Nitride. Okay, yeah. So now you go ahead to think about how about the bromine and the iodine. Okay, so bromine and the iodide, iodine. Okay, so go ahead to change the bromine and iodine to the ending with IDE. Okay, so this one you add the IDE. And you get rid of the INE over here, so that's called a bromide. And this one have a IDE. It's called a, get rid of this, iodide. That's interesting. Iodide. Okay. Okay, so this is how you make the ending for this monoatomic ion. That makes sense, right? Okay, yeah. So when you're then we can talk about, okay, if you have a compound, then how do we write a name? How do we write name? As long as you know what is the name for the cation and you know what is the name for the anion, then you know it, right? So for example, what is this called? So what are you gonna do? When you write the formula, give your formula to write the name. First, you need to know what is the ion, what is ion, what is the cation, what is the anion. Okay, for this one, the cation is this, and we know this is a magnesium, right? Magnesium has a 2 positive charge, and this is the anion, the oxygen. So what is the name for this? And what is the name for this one? Magnesium 2+ is just called the magnesium. magnesium is just magnesium ion, just magnesium. And this oxygen, so that's a oxide. So that's why that's called a magnesium oxide. And you need to double check, is the magnesium has multiple different ions? You're looking at it here? No. So that's just only magnesium. So that's called magnesium oxide, right? Okay, so for this one, then first you need to see, okay, I know this is iron, but what is the charge for this ion, right? Before you're talking about this, you need to make sure what is the charge for those ions, those cations, because some of this could have a multiple. And even for this one, definitely iron has a different kind of the ions. Then you need to see, okay, I know this is this cation is iron, but what is the charge for this ion? Then you can easier to see the anion, because anion never change the charge. Okay, so chloride ion has a 1 negative charge, and we have a 2 of the chloride ion, which means this guy have to have a 1 positive charge, 2 positive charge. So this guy is 2 positive, chloride ion is negative. What is the name for this ion? This is called the ion 3 or ion 2, right? Because they have a 2 positive charge. This is called iron 2. And then the ending is chloride. This one is the same thing. You're gonna write this is a 3 positive charge, and this is a 1 negative. So this is called iron 3 chloride. Are you clear? Are you clear? Okay. So this is how we write those. Okay, then go ahead to write the formula like this. Okay, give you a name of this. Give a name for the following 3 compounds. Okay, you need to make sure what is the charge for those cation and anion, and then you give it a name. Okay, so now you can look at here. So obviously, we know oxygen always has a 2 negative charge. So 3 of the oxygen make a 6, and 2 of the ions. So obviously, this guy is a 3 positive. So this guy has a 3 positive, and oxygen is 2 negative. So this guy is a 3 positive ion, which is this is ion 3. And this one is oxide. So this is called the iron 3 oxide.
And if you're looking at here, this is copper, right? Copper and then oxygen is 2 negative. We only have 1 copper, so this guy definitely is 1 positive or 2 positive. So this is copper 2 plus. So this is a copper
2 oxide. And then since this is still oxygen is 2 negative, but we have a 2 of the copper to balance it. So each of the copper should be 1 positive. So this one has a copper 1 and oxide. So this is called a copper 1 oxide. Now are you clear? Okay, yeah. So this is talking about for the monoatomic ion. And let's just then we're going to just talk a little bit for the polyatomic ion. So if we have a cation plus the polyatomic anion, in general, it's the same thing. Still, the name of the cation
plus the name of anion. But the polyatomic anion, sometimes they are complicated.
Okay, but today we're not going to talk everything. Or I just doing the introduction. Here, if you're looking at the polyatomic ion, some of this has their special name. For example, if you're talking about the OH minus, this guy is just called hydroxide.
This is hydroxide, right? So if we have a magnesium OH2 over here, the magnesium, we know that's called a magnesium. And the later, this is called a hydroxide. So the whole name, this one is just called a magnesium oxide.
Magnesium hydroxide. That's it.
And if you write FeOH3, then that's just iron 3 hydroxide. Right? So we're still follow the rule. Still follow the rule. Okay. And so what is this called? So what is this called? Looking at what is the name for this polyatomic ion, Ni? Cn. Looking at the polyatomic ion, what is the name? Cyanide. So what is this called? It's just called a sodium cyanide, right? It's called a sodium cyanide.
Is the sodium cyanide toxic? What do you think? Very toxic. Okay, just maybe just a little bit, it will let an elephant die. Yeah, very toxic. This guy. Okay, yeah, sodium cyanide. Okay, so if you have something called cyanide, better wash your hand after the lab. Okay, yeah, we will using some of the, but not exactly the cyanide. It's called a thal cyanide, but still cyanide. Okay, yeah. So you definitely need to wash your hands after that. Yes, please.
I was just wondering, why is it so like, what makes it so dangerous?
Why does it make it so dangerous?
Yeah.
Well, I'm not sure what exactly, but the CN is you see, this is a C, carbon and nitrogen. This is an organic acid. This is a kind of like an organic compound, and the cyanide will make the body. It will combine your body, some of the organism, and make it malfunction. Okay, yeah. Either is your liver or kidney, and then the whole body will die. Okay, yeah. So this is a sodium cyanide. Then if you're looking at for the polyatomic anion, there's a lot of the polyatomic ion, like a CO2 minus, SO4 2 minus, NO3 minus, and a PO4 3 minus. And by the way, those are the very common polyatomic ion. I hope you can circle that in your common ion sheet, and also you're gonna remember it. For example, hydroxide, only 5. I hope you can remember. Hydrogen, hydroxide, and this is called a carbonate, CO3 2 minus carbonate. Sodium, that's a sulfate, that's a nitrate, and this is a phosphate. Those are ions are very common in our daily life, like sodium, the carbonate, sodium carbonate, that's a baking soda. Okay, very common use. Sulfate, okay, sheetrock is made by calcium sulfate. Okay, sodium, nitrate, there's a lot of the preserved food has a nitrite. It's coming from the nitrate, and the phosphate. Our teeth made by calcium phosphate. Okay, yeah. So and also our body has a lot of nitrate up there. Very common polyatomic ion. So I hope you can remember the name of those. Not just the name, but also the charge. Okay. This is 2 minus, and the 1 minus, and 3 minus. Okay. Not just the name, but also the charge. So you see, this are kind of like a group of the polyatomic ion is always has a non-metal at first, and then has oxygen later. You see, non-metal, oxygen, and has multiple numbers of the oxygen. And we call this is one group of this polyatomic ion is called a oxyanion. It's called the oxyanion, and this is the oxyanion. So typically, oxyanion has their special names. Okay, they have a system and can give us a name for those oxyanion. Not for the hydroxide, not for the cyanide. They have a special name, but for this oxyanion, they do have a system to give us a name. Okay, so today we're not going to talk about those too much. I'm only just focused on those guys has 3 oxygens. Okay, 3 oxygens. So so let's just first talk about those 3 oxygens. So if we have if there are 3 oxygens, in oxyanion, so the name of that is just the name of the elements plus the ending as a ATE. Okay, so the name of this, the anion, polyatomic anion, is just any name of the elements plus ATE. For example, CO3 2 minus, we know this is called a carbonate. But why this is called a carbonate? Because the carbon and plus ATE ending. Okay, so we get rid of the end this, so you add them together, you got carbonate. Okay, oh sorry, this one don't have the, do not get rid of the end. There's no ending to be get rid. So this is just called a carbonate. It's called a carbonate. And if you have a nitrogen, This is nitrogen. And plus ATE. The same thing, you get rid of quite a lot of things. And this is called a nitrate. Nitrate, okay? Same thing like chlorine, ClO3 minus. Okay, ClO3 minus, and this is one is called the chlorine. Then you plus ATE. And get rid of the ending, then this is called a chlorate. Chlorate. Okay, yeah, you can find a chlorate in your common line sheet, but you cannot see this one. This one is the same thing. Again, this is a bromine, and you can think about what is the name for this one, and what is the name for this one. IO3 minus. This is a bromine. This is a iodine. You're gonna have a ATE ending. This one also has an ATE ending.
Okay, what this part? You're gonna get rid of some of those, right?
This is bromine. Get rid of the INE. So this is called a bromate. Okay, bromate. And this is iodine. You get rid of the INE. So this is called a aldate. Aldate. Okay. That makes sense, right? Okay, so those are the elements shows up there. And one more thing I would like to see, you see, chloride, bromine, iodine, those are in the same group, right? So these are in the same group, right? So if those guys in the same group, when they combine with the same oxygen, suppose they should have the same number of charge. Okay, so generally, so that's why we group them together, because they have a similar physical properties, right? So the chlorine, they have this guy, bromine, this guy, if they have the same oxygen, they suppose has the same charge. Okay, just the same thing. If you're looking at, if we have a sulfur, this guy has 4 oxygen, this guy has 2 negative charge. And if you not see this one, and what is charge of this? Selenium and sulfur in the same group. So selenium has the same oxygen, just like a sulfur, and generally you should have the same oxygen charge. Okay. And next one, if you have a nitrogen, has a 1 negative charge, right? Nitrogen has 1 negative charge. Phosphor, well, phosphor is different, but for the arsenic, yeah, nitrogen and phosphor is a little bit different.
Okay, so phosphor has a 3 positive charge. Phosphate has a 3
negative charge. And if you're 1 down there, arsenic, then generally it's the same thing, just like a phosphate. This guy should also has a 3 negative charge. Okay, yeah. So generally they have a trans shows up there. And the reason I'm talking about it is because the polyatomic ion didn't shows every elements their charge, right? For the polyatomic ion. Some of those, if you see the trans in the same group, you may see the trans for their charge of those ions. Any questions? Okay. So this guy, again, let's come back to see this. Those are polyatomic ion, and they're all end with ATE with
the 3 oxygens, but they have several exceptions. The exception is some of the elements like sulfur, phosphate, phosphorus, and selenium and arsenic. So for those elements, if they have a 4, if they have 4 oxygen, the name is end with ATE.
Okay, so this is a little bit different. This guy, so that's why you see when you write SO2 minus, this is called a sulfate. It's end with ATE. It's ATE. PO4 3 minus, this is called a phosphate. It's coming from the phosphor. SeO4 is 2 minus, this is called a selenite. Selenate. Okay, so this is end with ATE. And arsenic, SO4 3 minus. This is called arsenate. Okay, so those guys are all end with ATE. Some of this already shows in the polyatomic ion, but not all, everything shows up there. Okay. So this is what I'm going to talk about for today. Okay, and next class we'll continue to finish the naming, including the naming for the molecular compound. Okay, the naming for the acid, naming for the ionic compound, and naming for the molecular compound. Okay, so this is what we are going to talk about next time. Okay, so let's take a break and then we're going to come back. We're still going to do the practice over here in the study guide. Okay, I'm going to give you some of the questions. Okay, the page of the questions, and then you can work on this. As long as you finish it, and if you want to check with me, I can check with you. If you think everything is okay, then you're good to go. Okay, yeah.